Okay, we want to look at the number of vertices, faces, and edges that different shapes have. And what we're going to do is we're going to look at something called Euler's formula. And so what we want to do is we want to build the following to complete the chart. Well, let's think about a tetrahedron. A tetrahedron is basically a pyramid that has a triangular base. Okay? So if we think about the number of vertices, there's 1, 2, 3, 4 vertices. The number of faces, 1, 2, remember on the back side, 3, 4 faces. The edges, we've got 3 on the bottom, and then 1, 2, 3, so that makes 6 edges. Now, for a cube, and I'm going to come over here, so a cube right here, and I'm going to kind of lay this out for us because it's a little bit easier for us to see sometimes whenever it's laid out. Okay, and I'm going to zoom out some. Okay, so here's our cube that's laid out. We have 1, 2, 3, 4, 5, 6 faces. Then if we think about the number of vertices, and I'm going to put this back together. Okay, so the number of vertices, we've got 1, 2, 3, 4, 5, 6, 7, 8 vertices. So we have 8 vertices and 6 faces. Then let's look at the edges. We have 1, 2, 3, 4. Then we have 1 in the back, so that's 5, 6, 7, 8, 9, 10, 11, 12 edges. For a square pyramid, so a square pyramid, here's our square pyramid. Okay, we have 4 vertices there and a 5th vertice on top. So we have 5 vertices, we have 4 faces and 1 face on bottom, so that's 5 faces. And then I am going to come down here and I'm actually going to try to draw. We have 1, 2, 3, 4, 5, 6, 7, 8 edges. So we had 5 vertices, 5 faces, and 8 edges. Now for an octahedron, that has 8 sides, and so we're going to have 8 faces, 6 vertices, and 12 edges. A pentagonal pyramid. And let's go back over here because I do have one of those. I'm going to get rid of this one if I can. Let me try to, I'm going to, it's not letting me, okay, now maybe it'll let me get rid of this. Okay, let me, I want to move, oh no, I don't want to do that. Oops, okay. Let's get rid of, Okay, and I'll just move all of this down here so that it gets out of our way. How's that? Okay, so there we go. I just want to go back over here. And we are on the pentagonal pyramid. So we're on the pentagonal pyramid, which is this one. And if we look at this pentagonal pyramid, we have 5 sides with a base. Okay, so we have 5 sides and a base, so that would be 6 faces. We have 1, 2, 3, 4, 5, 6 vertices. With our number of edges, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 vertices. So for a pentagonal pyramid, we have 6, 6, and 10. We can do the same thing for our hexagonal prism. We're going to have 12, 8, and 18. For these two, you're going to have 20, 12, and 30. 12, 20, and 30. This is a 20-sided figure. This is a 12-sided figure. And what we actually come to find out is that there is a relationship between the vertices, the faces, and the edges. If you take the vertices plus the faces and you subtract the number of edges, you will always come up with the number 2. 12 plus 20 is 32, minus 30 is 2. 20 plus 12 is 32, minus 30 is 2. 12 plus 8 is 20, minus 18 is 2. 6 plus 6 is 12, minus 10 is 2. So you'll notice that's a pattern that you can look at.